Okay, question number 6, being able to determine whether the series is convergent or divergent. A couple of facts that we discussed in class about convergence test and divergence test. We arrived at a couple of important conclusions. Number 1, all arithmetic series are divergent, every single one of them. Okay, so look for that. If you can find one that is indeed arithmetic, then you have your answer already. You know, look at A. Notice we go from 13 over 2 to 11 over 2 to 9 over 2 to 7 over 2. You are decreasing by a consistent amount. Think about it from this perspective. We're really looking at 6.5, 5.5, 4.5, 3.5, so on and so forth. In other words, those numbers are decreasing by 1 each time. So when this series of fractions eventually reaches 0, it's going to go right past 0 and start giving us some negative numbers here. So this series is going to be divergent because the series itself is arithmetic. Now look at the other one there. Look at B. Close inspection here, we can tell that it's not arithmetic. You know, we're not adding the same amount each time. We're going from 1/6 to 1/24 and then to 1 over 120. So we aren't adding the same amount each time. So where you go next is check to see if the series is geometric. Some characteristics of a geometric series, as we know, is that the R value needs to be figured out here. Now you take a look at this thing here, definitely the R value is not the same going through here. You're going from 1/6 to 1/24, which means you're multiplying by a quarter. You multiply by a quarter, you're not going to get 1 over 120 like that third fraction is. So now what? What we have to do next is we just simply use the eyeball test. Let's look at this series here and let's figure that one out. And what you need to look for here is figure out if the series is going to have a limit. If the series looks like it's going to have a limit, then it's going to be convergent. If the series doesn't look like it's going to have a limit, then it's divergent. When you look at this situation up here, you're going from 1/6 to 1/24 to 1 over 120. Those denominator numbers get larger each time, but that numerator stays right at 1. So I think we're going to have a limit here of 0. And since we're going to have a limit, that means that we're convergent. Okay? But now going back to this geometric series here, a couple things to think about in order to figure out if there's convergence or divergence with a geometric series. Some geometric series can be convergent and some geometric series can be divergent. It all depends on the common ratio R. If your R value is greater than 1, that means the numbers are getting larger and larger each time, which means that we have a divergent series on our hands. If your R value is less than 1, if your common ratio is multiplied by a number that's a fraction, for example, those numbers are getting smaller and smaller and smaller and smaller, so we're dealing with a convergent series.